But I do love this topic. I've studied it for years. I do have an undergraduate degree in engineering. My undergraduate degree was in electrical engineering. Now, that was many, many years ago. I couldn't do that today if my life depended on it. But nonetheless, I did get a degree in that. I've always been fascinated by how I believe true science confirms the Word of God, how what we see in God's Word agrees with what we read in God's Word. And so that's always been fascinating to me. And so I want to talk about today the subject of the age of the earth that you could entitle as 6 days or millions of years. Now, it's interesting, the subject that Dan talked about today, even Christians that would call themselves older creationists, whether it's the day-age theory or if they hold to the framework hypothesis or the gap theory or whatever the case may be, probably all of them would agree with not maybe everything, but a lot of what you said tonight. As far as the information, God created the information that couldn't have arisen by chance. And so we'd have a lot of agreement between, let's say, the intelligent design movement and my position as what is often referred to as a younger creationist, although I prefer biblical creationist. But there'd be a lot of agreement. But on this topic, the age of the earth, that's a little bit different. That's where if you espouse that the earth is only 6,000 to 8,000 years old or something like that, you have certainly left the realm of science and you've entered the world of the tooth fairy and Santa Claus and make-believe and anything else like that. And that's really the way that the position that I want to espouse is viewed by a lot of people today. But nonetheless, having said that, I want to ask that question, 6 literal days or millions of years. If you believe in the prevailing paradigm about millions of years, and you also claim to be a Christian, you have got, in some way, shape, or form, to figure out where to put those millions of years in the biblical text. It's got to go somewhere. And there's a lot of different attempts at doing that, whether you place it between verse 1 and verse 2 of Genesis 1, where you spread it out over the 6 days of creation, or whatever you do, you've got to find somewhere to put those millions of years. But let me talk for a second about the Hebrew word yom. Now, Brother Reynolds, if you were with us Sunday morning, addressed some of this in his address to us on Sunday morning, so some of this is repeating what he said if you were here. But a lot of people say that word yom does not have to be a literal day. Now, that is true. The word yom in the Hebrew has a variety that's very similar to our English word day. All right, in different contexts, it can mean a literal 24-hour day, or it can mean an indefinite sort of period of time. Let me give you an example in English sentence where the word day is used 3 different ways in the same sentence. Back in my father's day, that's a general time period. It took 10 days, that's a 24-hour day, to drive across the Australian outback during the day. That's the time of daylight as opposed to night. So you have 3 different uses of day in the same sentence. And that Hebrew word can do the same sort of thing. However, whenever that word yom is combined with a number, any other time in the Old Testament, that occurs 410 times, it always means an ordinary day in every other instance. Whenever the word morning or evening occur together without day, 38 other times in the Old Testament, it always means an ordinary day. Evening or morning together with the word day occurs 23 times, always means an ordinary day. Night with day, 52 times, always means an ordinary day. Now, when we read the text of Genesis 1, it almost seems like God is trying to tell us something. Does it not? There was an evening and a morning, the first day. There was an evening and a morning, second day. There was an evening and a morning, the third day. Clearly saying there's a period of daylight, there's a period of nighttime, or darkness, that's a day. Another period of daylight, another period of darkness, that's a day. It's almost like God's defining His terms for us in the text to make sure that there will be no confusion later on. And that's what the text says. Let me give you a famous quote, very controversial quote. Dr. James Varr, who was once a Hebrew scholar at Oxford, said this: so far as I know, there is no professor of Hebrew or Old Testament in any world-class university who does not believe that the writer or writers of Genesis 1 to 11 intended to convey to their readers the idea that a creation took place in a series of 6 days, which were the same as the days of 24 hours we now experience. Now, this quote is significant because this guy is not a Bible believer. He's not a conservative. He's not even sure that Moses wrote Genesis. He actually was neo-Orthodox, if you're familiar with that theology. So he does not personally believe that the universe is only 6,000 years old or whatever. He doesn't personally believe that. But he believes that's what the writers of Genesis intended to convey. Now that's a controversial quote because opponents will say you can't use that because that guy didn't believe the earth was young. Well, that just said that's true, but there's been other quotes, and I don't have time to give them to you, but I've got some other quotes I could show you if you want after from modern Hebrew scholars who are more the liberal variety, who are basically saying exactly the same thing. And you have something very unusual. You, in essence, have, if you look at the literature, there's almost an agreement between the most conservative Bible scholars and the most liberal against evangelicals who want to have millions of years in the text. All right? And the liberal guys who don't care whether the Bible's accurate or not, they have nothing to lose. So they say, no, of course the writer intended 24-hour days. No, I don't believe that. I think he was wrong. But of course that's what the writer intended. And that's what Hebrew scholars will say today. Now, that being said, I want to lay a foundation. I don't have the time to go into any detail. I've got a whole other lecture that I did last year on presuppositions and bias in the creation-evolution debate and how those presuppositions flavor the way we always look at evidence. But what I want to briefly say is we can look at the same evidence. And whether we're starting with God's Word is true, sola scriptura, or whether we're having the idea man decides truth, we're going to come up with very different conclusions from that same evidence. For instance, I can dig up this, or let's say an evolutionist digs up this dinosaur fossil. He assumes the Earth is millions of years old. He will always interpret that find consistent with evolution and an old Earth, and all contrary evidence is going to be explained away. Always. Now, I've got to be honest. As a young Earth creationist, I'm also biased. If I find this same fossil, imagine I was a paleontologist and I find it, I'm going to interpret it consistent with the Bible in a young age. I don't deny that. I don't deny my bias because I already believe that's the case. So the bottom line is everyone's biased. It's just that some people admit their bias and some people do not. So with that in mind, I want to suggest this. There are actually hundreds of different physical processes that set limits on the age of the Earth. Now, no one of these can give you there's no scientific process that you can use to say that this is exactly how old the Earth is. That cannot be done. All right, but there's a whole litany of processes that you can use that will set apparent, or like, let's say, upper ages. In other words, the age could be less, and with these different processes, some of them give thousands of years, some of them give millions of years, but the vast majority give less than billions of years. And keep in mind, to an evolutionist, millions of years is nothing. They've got to have more than that for the age of the Earth. Now, and I've got to go through all this quickly because I don't have a lot of time, so I'm going to try to go quickly, so bear with me, and I'll try to make it clear. But let me first of all talk about the methods that do give billions of years. Some of the radioisotope dating methods, and these are the ones that you're probably most familiar with, you've heard about a lot, that give billions of years of age for these igneous rocks that they date around the Earth. I think most of us have a basic understanding of how this works with radioactive decay. The nucleus of an atom changes into a new element. For instance, carbon-14 over time decays into nitrogen-14. And so we know about that. Let me give you a quote from a textbook. 1998 textbook. Using radioactive dating, scientists have determined that the Earth is about 4.5 billion years old, ancient enough for all species to have formed through evolution. Well, if you understand what Dr. Reynolds just said, no, you can have eternity at your disposal when it's not going to happen, all right? But nonetheless, they claim that if you have that much time, anything is possible. So they've got to have the billions of years for their biological theory. Let me give you a quote from an evolutionist that says it's obvious that radiometric techniques may not be the absolute dating methods they're claimed to be. Age estimates on a given geological strata by different radiometric methods are often quite different, sometimes by hundreds of millions of years. There is no absolutely reliable long-term radiological clock. The uncertainties inherent in radiometric dating are disturbing to geologists and to evolutionists. But here's a guy that's honest and saying you take these rocks and you date them by different methods and you get very, very different results. In fact, you can often date a rock the same method in two different times and get very different results. So they're not as reliable as they're claimed to be. Now, these are a couple examples of the type of methods we can use. Uranium decays over time to lead, potassium to argon, uranium-238 more technically decays to lead-206 over time, and basically it's a series of steps. Along the way, alpha particles, which are equivalent to helium atoms, are emitted in the process. All right, but over time, uranium-238, through a series of steps, eventually decays to lead-206. So you can take a rock and you can examine it and try to determine how much uranium-238 is there, how much lead-206 is there, and try to determine it in the age of the rock. But to do that, you've got to make certain assumptions. There are actually 3 assumptions that you've got to make. First of all, the starting amount of daughter element is assumed to be known, and oftentimes the assumption is it's 0 or very little of it. So it's assumed most all of the daughter element was because of the radioactive decay process. The second assumption is that the sample was always in a closed environment. In other words, throughout the whole history of that rock, there's never been any lead or uranium added or taken away from it. It's always been closed so that that never happened. And the third assumption you have to make is that the decay rate has always been constant. Now, if any of those assumptions are wrong, your result is going to be wrong. Now, as young Earth creationists, we have reasons to doubt all 3 of these assumptions. The third could be invalid if the radioactive decay rates were changed at any point in the past. A lot of creationists believe at the time of the flood that perhaps these rates were different. Matter of fact, it's also been shown, the footnotes are referring to laboratory experiments that show under certain conditions, even in the laboratory, you can show that these rates can be changed. Matter of fact, there's a group of creation scientists called the RATE group, standing for radioisotope in the age of the Earth, and these guys actually believe that they have found some evidence that they believe indicates that there has been an acceleration of the decay rates at some point in the past. I'll mention a little bit more about that maybe a little bit later. But let me talk about assumption number 2 right now. It's very unlikely to be true. Since there's no such thing as a closed system in the real world, it's very unlikely that a rock would be closed for 1 billion years of fracturing, folding, solvent action, and other such phenomena just sitting there all that time and nothing happens over billions and billions of years. The first assumption, I would argue, is the least likely to be true. Because again, how do we possibly know whether there was any of the daughter element there at the beginning? You've just got to assume that that wasn't the case, and there's really no way to know that. Now let me illustrate those 3 assumptions with this sort of ridiculous illustration. It's called the parable of the potato basket. Actually, John Morris from the Institute for Creation Research came up with this illustration. But it's the uniformitarians and their 3 assumptions. All right, let's imagine that maybe you're going to NC State over here, you've got a class that starts at 3 o'clock, and you go in, you're a little bit early, you sit down in the classroom, and there's this guy up there in the front, this crazy professor, this guy's a nut. He's up there peeling potatoes, of all things. All right, and he's peeling potatoes, and each time he's done with the potato, he puts it in the basket. And you start timing the guy. You get a stopwatch with you, you start typing, and he's like clockwork. Every 60 seconds on the minute, he finishes another potato, he puts it in the basket. 60 seconds later, he finishes another potato, he puts it in the basket. Now let me ask you a question. If there's 20 potatoes in that basket, how long has he been doing that? 20 minutes is what I heard, and that's a logical conclusion based on your assumptions, but what if your assumptions are wrong? For instance, maybe before you got there, someone came along and added more potatoes so that the rate was a little bit faster at that point in time, and you didn't see that. Or maybe someone came along and took some potatoes away, maybe ate some, or whatever the case may be before you got there, and you didn't see that. And furthermore, you're just assuming he walked in with an empty basket, right? How do you know he didn't walk in with a basket that already had potatoes in there? And so all 3 of your assumptions have to be correct for your answer grade. If you're a mathematician, you know you can do all the steps correctly, but if you started out with the wrong numbers at the beginning, your answer's still going to be wrong, even though you did the math correctly. So what we can do is we can use these methods, these radiometric methods, we can sort of test them out by dating igneous rocks. And by the way, you can only use these methods on igneous rocks. You can't use them on the sedimentary rocks where the fossils are. A lot of people don't understand that. Sedimentary rocks can't even be dated with these methods. All right, but you can take the igneous rocks and you can date it. Take, for instance, Sunset Crater. I had a chance to see that a few years ago out in Arizona. We know it erupted. There's Indian artifacts there. We know it erupted about 1065 AD. Was potassium argon dated to 200,000 plus years. Or a lava flow in New Zealand that erupted 3 different times, 1949, 54, and 75. Potassium argon dated at 275,000 years. Or this particular eruption in Hawaii, erupted in 1801, potassium argon dated at 1.4 to 22 million years. Or Mount Etna in Sicily, potassium argon dated 140,000 to 350,000 years when it erupted in 1972. Now let me give you one that's more famous to all of us, and that would be the eruption of Mount St. Helens that a lot of us remember from 1980. I can definitely remember that. I was 14 years old. You can do the math, figure out how old I was, but I can still remember. All right, that was a huge, I mean, that was huge. For a volcano to erupt in the continental 48, I don't know the last time that had happened before 1980. And it was one of the most watched geologic events in the history of the world. I mean, there were geologists there for months ahead of time, just mapping it out and watching what happened. So the question is, there's a lava dome. How old is that? Well, we know it's got to be less than 37 years, right? Because it initially erupted in 1980. We know that. How old does it date? Well, some creation scientists took some samples and sent them to secondary labs, and they got a range of dates, but the oldest date they came back with was 2.4 million years for a rock that was formed in 1980. So we know that there's something that's not right with the method. So the point of this is, if the dates aren't right when we know the age of the rocks, how can we be sure they're correct when we don't know the exact age of the rocks? And that's what I would like to ask. Quote from John Morris: when the same rock is dated by more than one method, it will often yield different ages, and when the rock is dated more than one time by the same method, it will often give different results. So if you base your theory on the wrong assumption, all your work can be correct, but the result will be wrong. Now, what I'd like to do in the next few minutes is look at some other ways that you can calculate an apparent, and again I use that word apparent, no one can precisely calculate, but an apparent age of the Earth. There's several other ways that we can do that give relatively young ages. All right, at least compared to what the evolutionists need. And I want to just talk about a few of those. One would be the Earth's magnetic field. All right, we know that the Earth is like a bipolar magnet. It's got a north and a south pole. We can calculate how strong that is. We've done that. We know it loses its energy every 1,450, 40 years. Half of its energy, that's its half-life, in other words. We know, let me go back. But based on the calculations, by the way, it's decreased 7% since 1829. We've calculated that. But if you go back in time, only 20,000 years ago, the field would have been so strong it would have basically fried the Earth. The internal structure of the Earth would have been disrupted by the heat from that field. And so logically, you would therefore conclude that the Earth has to be less than 20,000 years, assuming the strength has always been the same, and assuming the same assumptions that we talked about. If that's the case, then you would assume the Earth has to be less than 20,000 years old. Let me give you another example, the amount of helium in the atmosphere. I've already talked about how through radioactive decay, helium atoms basically come out of the rocks and they slowly diffuse into the atmosphere. And we actually, I don't know exactly how they calculate this, but they have calculated the rates in which helium is being added to the atmosphere, and they've calculated the theoretical rate in which some, not nearly as much, but escapes into outer space. From what I've read, approximately 13 million helium atoms per square inch each second are being introduced in the atmosphere. And the theoretical rate of escape is about 0.3, let me go back. Got to read my note here, about 0.3 million atoms per square inch per second. So the bottom line is the amount of helium is building up very rapidly in the atmosphere. And if you do the calculations, if you assume there was absolutely none there to start with, which I don't think is a good assumption, but if you assume there was absolutely zero to start with, all of the helium that's there now would accumulate at a maximum of 2 billion years. Which again, logically, you would assume then the Earth has to be less than 2 billion years old from that method. Sort of summarizing this, we know that radioactive decay produces helium atoms. It doesn't remain in the rocks long. It migrates rapidly to the surface and into the atmosphere. If the Earth is billions of years old, we shouldn't find large amounts of helium in granite rocks, for instance. And particularly, I'm going to give you an example with zircon crystals in the granite rocks that I'm going to talk about for a second. Matter of fact, let me just talk about that. The rate, I talked about the rate scientist earlier. They did an experiment a few years ago where they took a granite rock that they had gotten in New Mexico from a borehole, and they did some studies on this particular rock. It had zircon crystals in the rock, and inside the zircon crystals were both uranium and lead, and there was radioactive decay going on there. And they dated the rock at 1.5 billion years using the uranium-lead dating method to do that. However, what they found was there was a lot more helium left in the rock than they expected. They expected that after that amount of time, most all of the helium would have left the rock and entered ultimately the atmosphere. And what they did, and this is controversial. I've read some articles online where some old earthers disagree with the rates that rate group used for the diffusion of the helium, and there's controversy back and forth over that, and you can do your own research. But according to the calculations of the rate scientists, there was about 5,680 years worth of helium left in those rocks, even though there was supposed to be 1.5 billion years of radioactive decay. So their conclusion was, agree or disagree with it, they believe that the decay rate was faster in the past. All right, was the conclusion that they came to. Okay, let me move on. Let me talk about also the amount of salt in the sea. We know approximately how much salt is being added to the sea each year, about 450 million tons per year. Only about 27% of it gets out each year. So once again, the amount of salt is accumulating year after year after year in the sea. Again, if you assume there was no salt there to begin with, and you assume the amount of salt being added is always the same, it's never changed, it's always been consistent, and I would add at the time of the flood, it probably wasn't consistent. If you believe in the flood, there would be a lot more added during that time. But nonetheless, if that's your assumption, you get a maximum age of 42 million years to the age of the sea. If the sea really were billions of years old or millions of years old or whatever, you should practically be able to walk across it because of the amount of salt in the oceans at this point. And so there's just not enough salt in the sea. How about carbon-14? Carbon-14 dated method is often misunderstood. It cannot give millions of years. Some people think that carbon-14 dates give millions of years. Carbon-14, that method can only be used on things that were once alive. It can be used on bones, it can be used on wood, it can be used on anything that was once alive. But it has a maximum age of about 60,000 years before it's not detectable. So simply put, anything that's older than 60,000 years, you wouldn't detect any carbon-14 there. I'll show you how the dating method works in a second. But what is significant is that we have found carbon-14 detectable in coal and also fossilized woods that are supposed to be over 200 million years old. You still find radiocarbon. And it should be all gone by then. It should be gone in 60,000 years, and yet you find it in these coal samples or these woods that are supposed to be millions of years old. Now here's how it works. When something's alive, it's breathing in air, and that air and taking in food, and the things it takes in its body contain both carbon-14 and carbon-12. Carbon-14 is the radioactive variety, decays over time back to nitrogen-14. Carbon-12 is your everyday variety of carbon. So when something dies, it no longer takes in any new carbon-14, and the carbon-14 begins to break down till about, and again, 60,000 is just an estimate, but until about that point where there's no more detectable carbon-14 anymore. And so what you can do, you can take something that's used to be alive, that's dead, you can measure the amount of carbon-14, the amount of carbon-12, and calculate an apparent age for that organism. But again, what is fascinating is that this is an example where diamonds, and diamonds, by the way, are the hardest substance known. And so there's no way you can possibly contaminate a diamond. Sometimes people will argue that maybe some of these samples have been contaminated, and that's why you've got this carbon-14 that came from outside. It really wasn't initially there, but I can't even conceive of how you can contaminate a diamond, and yet even diamonds have measurable amounts of carbon-14, which says that they have to be less, and in this case they measured 58,000 years old, but they have to be less than 60,000 years of age. A very, very strong argument, I believe, for a young age of the dragon. So let me summarize this. Carbon-14 can only be used to date organic material. By the way, this is another point. The accuracy is dependent upon a consistent ratio between carbon-12 and 14. And scientists have calculated that it would take about 30,000 years to reach that equilibrium, assuming that you started out with an atmosphere that didn't have any of the carbon-14. But we know that it's not reached that equilibrium. It's still about 25% out of equilibrium, which again is another argument that the Earth should be less than 30,000 years old. And so again, if you look at carbon-14, it's a strong argument, I believe at least, that the Earth is relatively young. Now let me look at a couple other things. Let me talk about the age of the universe. Are we being told all the evidence or just selected information to support a particular idea? Let's take, for instance, the recession of the moon. Now this was a big article in the news just a couple weeks ago when we had the eclipse. I think I heard 2 or 3 different times somebody talking on TV or on the radio about if you wait, I forget how many, millions, billions, however many years, you won't be able to see these eclipses anymore because the moon is very, very, very slowly moving away from the Earth, and they'll get to a point that it'll be too small, it will no longer completely cover the disk of the sun. Did anybody else hear that? I heard that on 2 or 3 different news outlets or whatever. And by the way, it is amazing that even though the sun is much larger than the moon, their relative size in the sky is exactly the same from planet Earth, and it's the only planet we know anywhere that's like that, and it happens to be the only planet that matters because we're here to see it. And did that just happen by chance, or did God kind of do that for our benefit? It's something interesting to think about. But nonetheless, the moon is slowly moving away from the Earth. All right, based on Newton's third law of motion, causes the moon to accelerate in its orbit, so it slowly spirals away from the Earth. Now, very, very insignificant, seemingly, 4 centimeters a year, so it's really nothing for us to worry about in our lifetimes. That's not very significant at all. But if you take that back into the past, and you assume that it's always been doing that for millions and millions and millions of years, and that rate has always been the same, then you've got problems. Only 1,000 years ago, if it was 1,000 years ago, the moon would have been 125 feet closer to the Earth. Big deal, and that's not significant. However, 1 million years ago, it would have been 28.4 miles closer to the Earth. 10 million years ago, it would have been 284 miles closer. 100 million years ago, it would have been 2,840 miles closer. 1 billion years ago, it would have been 28,400 miles closer. 1.4 billion years ago, it would have been contacting the Earth. Now, it would have been destroyed far before that. There's something called the Roche limit, which is the absolute maximum the moon could possibly be to the Earth without it being destroyed. But obviously, that could not have happened. And so that tells us that either something was very, very different in the past, or maybe the Earth and the moon aren't as old as we're being told. Let me move on past that. How about comets? We have both long and short period comets. Well, we have examples of both. The short period comets, like Halley's Comet, come around much more frequently. The long period comets, a long, long time before we ever see them again. There's 2 different kinds, but every time a comet goes around the sun, some of the material is burned away by the sun, and it's a little smaller the next time it comes around. And you can calculate that for the short period comets, they shouldn't last more than about 10,000 years at the absolute most. For the long period comets, it'd be about 100,000 years at the absolute most. And yet we still have all these comets. And so the question is, why aren't they all burned up? If the sun has really been around that long, it should have burned them all up by now. So where do we get these comets from? Why do we still see them? And so they have to come up with these rescue devices to rescue their theory. And what they've come up with are a couple things. Number one, they come up with the Oort cloud. All right, the Oort cloud is this theoretical cloud outside our solar system that no one has ever seen or observed, but occasionally it spits new comets into the solar system. Never been seen, never been observed, but it has to be there because we still have comets. Again, no evidence that it exists, but they believe it does. Let me give you a quote. Well, the Oort cloud has yet to be observed. The theory accounts so well for the distribution of comets' orbits that most astronomers today accept its existence. And by the way, let me give you the definition of faith: an unquestioning belief that does not require proof or observation. That'd be a great example of faith. It's an article of faith. Who said this? Many scientific papers are written each year about the Oort cloud, its properties, its origin, its evolution, yet there's not yet a shred of direct observational evidence for its existence. That was Carl Sagan. The late Carl Sagan said that. The Kuiper belt, by the way, is their explanation for the short period comets. That's supposed to be this field of objects, I think, past the orbit of Neptune, and the short period comets come from there. But again, theoretical observation, there's not nearly enough objects out there, and the objects that are there are too big, and again, there's just no observational evidence for that at all. So comets are very hard to explain under an old Earth scenario. How about galaxy formation? Spiral galaxies like our own Milky Way are very hard to explain in the ancient universe. The stars and the inner arms rotate more quickly than the stars in the outer arms. It's kind of like a figure skater in the Olympics, and you've all seen this. They're skating in a circle and they move their arms in, and what happens? They go just so much faster. And so it's just the same idea here. So really, after a few rotations of these arms, it should basically just become a circular disk, and you would no longer be able to see the arms. So if the galaxies are really as old as they claim, we shouldn't be able to see the spiral arms anymore. So that's another problem. I'm going to keep going for the sake of time. This is a slide, not of a real opal. Well, it is a real opal in one sense, but it's an artificial opal. It's created in a laboratory. And you would think it takes millions of years to create something like that. It doesn't take millions of years. It just takes the right conditions because they've done it in a laboratory. In the same way they have made coal in a laboratory. It doesn't take millions of years to form coal. It just takes the right conditions. And so that's something to remember. Or stalactites and stalagmites. I don't know how many of you have ever been on a tour of a cave or a coal mine or something like that. And I get so tired of hearing this, but the guide will say these things take millions of years to form. As they drip down over millions of years, they form these stalactites. And yet, let me give you this quote. Jerry Trout says that through photo monitoring, he has watched a stalactite grow several inches in a matter of days. Or how about this picture of a bat that's been covered by stalactite material? Now, does anyone think that that sat there for millions of years without decaying while it was being covered by that material? Of course not. Or how about this? This has been huge in the news recently, the discovery of soft tissues in dinosaur bones. And of course, some of you know that the original paper about this was authored by Dr. Mary Schweitzer, who is now a professor right here at North Carolina State University. And she is the one, her and her team, that initially made this discovery. They were looking at the T-bone, Rex bone, under the microscope. All right. And by the way, this quote is basically saying that dinosaur bones, we just assume they're all fossilized. Most dinosaur bones are not completely fossilized. They're not all rock. There's some bone material still present, in some cases more than others. But here's the quote. A thin slice of T-Rex bone glowed amber beneath the lens of my microscope. Blood vessel channels snaked through a bone matrix, and tiny chambers known as leucani, which house bone-forming cells, appeared as small ovals. Then a colleague took one look at them and shouted, "You've got red blood cells, you've got red blood cells." And that's what they were looking at. No one would have ever thought of even looking at a dinosaur bone under a microscope to look for that before this time. At least none of the old earthers would have. None of those that believe in millions of years. And that's the type of thing they found. And notice the red blood cells there. And by the way, let me just make it very, very clear. Dr. Schweitzer does not believe that the bones are young. She still believes they're millions of years old. She is actually trying to come up with explanations of how the material can be preserved for millions of years. Okay, that's her take on it. But nonetheless, this is an example where she's demonstrating this to someone who's a skeptic that it could actually happen. And she's showing them two photographs side by side. She says one of these cells is 65 million years old and one is about 9 months old. Can anyone tell me which is which? And they couldn't tell the difference. And Schweitzer herself says that leaves us with two alternatives for interpretation. Either the dinosaurs aren't as old as we think they are, or maybe we don't know exactly how these things got preserved. Now she is focusing on this explanation and ruling out this explanation because of her preconceived ideas that the Earth is millions of years old. She's already sort of determined that in her mind, and so she's only looking at one of these alternatives as a possibility. Remember I told you at the beginning that the way your biases and your presuppositions that you enter the debate with will determine your outcomes, your conclusions? All right, that's a great example of this. She says it was exactly like looking at a slice of modern bone, but of course I couldn't believe it. I said to the lab technician, the bones after all are 65 million years old. How can blood cells survive that long? Well, my question is, how do you know it's 65 million years old? Why don't you question that assumption? Maybe they're not that old. This is a creation scientist, Marcus Ross, who is, in his quote, is basically showing us that after she basically invented a new field of science. Molecular paleontology was never heard of before, really, before Mary Schweitzer. And now what they're doing is they're taking bones off of shelves in museums and looking inside of them, and lo and behold, what are they finding? They're finding all this soft tissue. The evidence keeps mounting. More materials have been discovered. Different types of proteins have been identified in laboratories, and now there are mounting evidences coming in from a wide range of types of different fossils from the so-called age of dinosaurs. Tyrannosaurus rex, Triceratops, duck-billed dinosaur, even dinosaur eggs. They're finding proteins. They're finding all kinds of different things in these dinosaur bones. Now, they are trying to come up with explanations, and if you want to study this more thoroughly, Echoes of the Jurassic by Kevin Anderson is a wonderful little book that even talks about some of the explanations they're proposing for how this material could last for 65 million years. I don't think they're good explanations, but nonetheless they're trying to come up with. All right, but I believe it's strong evidence that the bones aren't as old as we're being told. Now, I don't know if I have time. I'm going to have to rush through this. I wanted to talk a little bit about geology, and I'm going to rush through these slides here, which are more verbiage. But basically, in geology, you have a debate between catastrophists and those who hold to uniformitarianism, just like you do in biology between creation and evolution. All right, and uniformitarianism is simply the idea that the present is the key to the past. Things operate today the same way they've always operated. The same processes we see today are the processes we saw in the past. And you explain the present, you explain the past by what you see in the present. Catastrophists, in contrast, and by the way, uniformitarianism began late 1700s, early 1800s. Charles Lyell, James Hutt, and some of these guys came up with this idea. But a renewed emphasis on catastrophism began in 1961 with the publication of the book The Genesis Flood by John Wickham and Henry Morris, who began to look again at the evidence from a perspective of a biblical young earth. And since that time, there's been a field of science within creation science circles called catastrophism. All right, and basically uniformitarianism believes that all the rocks form gradually over time. Catastrophists believe the rocks were laid down one after another in a short period of time. And again, I'm going to have to do this at warp speed, but bear with me. And let's look at the claims of uniformitarianism versus the claims of the Bible. If the Genesis flood really occurred, then there were no geological ages. In other words, all of these different layers that the uniformitarians would claim represents different epochs or millions of years worth of time actually were all laid down very rapidly one after the other. And this is your typical geologic time chart. You've probably seen these in geology textbooks and things like that. But I want to make this very clear. You cannot go outside of this building and dig down in the earth and find these 12 layers underneath the ground. You can't do it. Matter of fact, of these 12 layers, 2/3 of the world's land surface has 5 or fewer of those 12 geologic systems represented, and 1/5 of the world's land surface has 3 or fewer of those layers represented. If the whole column were actually present, it would be 100 to 200 miles thick. However, the average thickness around the world is about 1 mile, and the greatest thickness anywhere is only about 16 miles. So what this is more or less a compilation of rock layers from all over the world sort of put together into one sequence. But you're not going to dig down outside and find that. Okay? So let's talk about fossils in the flood very quickly. If it really was a worldwide flood, as described in Genesis 6 to 9, what would you expect to find as evidence? Well, you'd expect to find, as Ken Ham says, billions of dead things buried in rock layers laid down by water over the earth. Well, what is it we actually find? Well, we find billions of dead things buried in rock layers laid down by water all over the earth. That's what we find. And that's what we would expect to find if there was a worldwide flood. Now, are there evidences for that? Now, most of the material I'm going to give you now comes from John Morris's book, The Young Earth. I'll give him credit here. And again, I'll rush through these. But one evidence is the worldwide presence of sedimentary rocks, by definition laid down by moving water. All right, as sediments drop out. And those rocks are all over the world. Furthermore, there are marine fossils inside those sedimentary rocks all over the world. You can go to the top of Mount Everest and find fossilized clams. So there are marine organisms in these sedimentary rocks all over the world. Furthermore, when you think about fossils, when something dies, it doesn't typically turn into a fossil. It decays or is eaten by scavengers or whatever. It actually has to be buried very rapidly if it's going to fossilize. So that's a rare occurrence. And sometimes you can see examples in the fossil record that it had to happen instantaneously. I took this picture at the Field Museum in Chicago. Here's a fish swallowing, a fish just captured and dying. Had to occur instantaneously. And so, again, if the Genesis record is true, we would expect to see all this fossilization. And by the way, it doesn't take millions of years to turn something into a fossil. It just takes the right conditions. Here's an example of a petrified ham. Or here's petrified flour. Or here's petrified fence wire. Or here's a petrified water wheel. Does anybody think that sat there for millions of years before it turned into solid rock? It doesn't take a lot of time. It just takes the right conditions. Now, moving on, the existence of vast fossil graveyards. There are places on the planet where you can find millions and millions of fossils just jumbled together in one location, unlike anything we see going on today. Sometimes it's the same animal, sometimes it's different animals. You have to ask what on earth was going on to cause that. Or the existence of the so-called fossil fuels, the coal and oil deposits that we don't see being formed today. And by the way, coal definitely is deposits of plant material at one time. The numerous examples of out-of-order layers in the geologic column. That column I showed you earlier, once in a while you actually have layers that are inverted in the wrong sequence. Sometimes you have whole sequences, sometimes you have individual fossils that are anomalies. You can have names for them. Stratigraphic leaks or reworked specimens that they're found in the wrong place. Now that's not necessarily frequent, but it does happen. And so we have anomalies like that. Now, if catastrophism is true, then all these layers that they say are evidence of millions of years of time has to have been laid down again one after the other, rapidly, catastrophically. And actually, there is a group of geologists today that are jettisoning the old idea of uniformitarianism. They don't accept a biblical account, but they're called neo-catastrophists, and they actually believe that the history of Earth is basically, well, let me give you this quote. The history of one part of the earth, like the life of a soldier, consists of long periods of boredom and short periods of terror. In other words, there's long periods of time where nothing's happening, then you have a local catastrophe that lays down all these sediments, and then long periods of time when nothing happens, and then another local catastrophe, and they explain the fossil record that way because they see evidence of catastrophes. And so they're trying to make sense of the evidence that they're seeing. So what we've got to do as young Earth creationists is somehow find a way to try to tie all those layers together into one continual process. How can you do that? One way is the fact that there's no worldwide unconformity in the entire geologic column except at this very base. If you saw the movie last night with us, it's Genesis History. It talked about the great unconformity. What was down at the very base, of the geologic column. But after that, there is no worldwide unconformity. Now, what's an unconformity? It's an evidence of time. Here you have what appears to be erosion or a stream bed or something like that. So clearly the rocks under here were laid down much earlier in time than the rocks above them. Where here you have rocks that have been shifted so that they're no longer horizontal. Clearly that's an evidence of time. There's time that passed between those rocks and the rocks above them being laid down. Down here, this is something called apparent conformity. A lot of uniformitarians say there are millions of years of time between those layers, but you can't tell it. So it's called apparent conformity. All right, so limited extent of unconformity. The point is that even if two series of rocks are unconformable at one point, if you trace them out far enough, eventually they'll be conformable and you can work your way up the entire staircase in a sense that way. Or how about the existence of polystrate fossils? This is one of my favorite evidences, and that is fossils that extend through, fossilized tree trunks, for instance, that extend through several geologic layers. And each one of those layers might represent millions of years of time to the uniformitarian geologist, and yet did that tree stand there for millions of years without rotting or decaying? I'm from the state of West Virginia, and in the West Virginia coal mines, they have things called kettle bottoms, which are these fossilized tree stumps that they find in these coal mines, and that's basically what's happening. They're extending through oftentimes multiple layers. And so I have no idea how they account for that. All right, that is a definite evidence for a quick continual deposition. Or how about the presence of short-term surface features like ripple marks, raindrops, animal tracks in the layers? Here's an example of raindrop impressions. How quickly did that have to be preserved? Or ripple marks like in sand in the ocean, or of course tracks like dinosaurs or whatever animal made them. They have to be preserved very, very rapidly, or they wouldn't be preserved at all. How about the deficiency of bioturbation? What on earth is that? Well, that's evidence of time, where you have evidence of like worms in the ground, or clams in the ground, or plant roots, or something like that. That would indicate a passage of time. You just don't see that in the fossil record. In like manner, the lack of soil layers would be another evidence for a significant period of time between the layers are not there. And undisturbed bedding planes, that's the idea of these knife-like edges, just flat as a pancake. This is Grand Canyon, and you have the Hermit Shell and the Coconino Sandstone. And notice this flat as a pancake type, boundaries, the word I'm looking for, between the two layers. And if there really is time between these two, there ought to be evidence of erosion or something there. But you just have this flat line. Soft sediment deformation. This is a section of the Grand Canyon showing the Kaibab upwarp is what they call it, all these different layers that are here. And these rock layers, these solid rock layers have been twisted. Notice these incredible angles here. Notice these rocks doing the Watusi there. Now let me ask you a question. Can you bend solid rock that way? What happens when you try to bend solid rock that way? It breaks, it crumbles.
If it's lava, you can form it that way.
Okay, fine. But this is sedimentary rocks. Okay? The only way you could get this if the sediments were still soft. And they were deformed while they were soft. They were laid down while they were soft, and then there was some uplifting that was occurring, and it caused the sediments to shift, and you could get a scenario like that if they were soft. So under the older scenario, the sediments were brittle and deformed. That wouldn't happen, but under a younger scenario, if the sediments were still soft, you could understand how that could happen. So again, I went very quickly, but some of you may disagree with me, and you're welcome to do that. And again, I can't prove the earth is young. I never claimed I could do that. You can't prove the earth is young by the scientific method. You can't do that. But what I'm trying to argue for is this. If you look at all these different ways that you can come up with dates for the earth, apparent ages for the earth, and the ones that we've looked at this evening, I believe that using observational science, they're better explained by a young earth creation model than by an evolutionary model, by a uniformitarian model. I think the evidence is better explained by a young earth creation position. You're free to disagree, but that's the conclusion that I've come to. And let me finish with this thought. Why is this important? If we're just going to argue about the age of the earth, I could care less whether we win or lose an argument. Who cares? If it's 6,000 years or 4.5 billion years old or whatever they're saying now, who cares? If we're just arguing about the age, why does it even matter? It doesn't. If that's what it's all about. But see, the problem is, if the earth is really that old, and if you believe, therefore, in some sort of evolution, whether it's Darwinian evolution or whether you believe that God guided the process through some form of theistic evolution, you've got to believe in millions of years worth of death, bloodshed, and survival of the fittest before you ever get to mankind. It's probably not even a literal atom, it's a group of men. So death is part of the process that leads to our existence. In contrast, though, if you believe in biblical creation, then death is an intruder. According to the Bible, because of, let me show you the verse, Romans 5:12, wherefore as by one man sin entered into the world, and death by sin, so death passed upon all men, for all have sinned. In other words, death came as a result of Adam's sin. There was no death before sin. And Romans 6:23 tells us that the wages of sin is death. God said to Adam and Eve at the very beginning, if you disobey, you're going to die. That was the penalty for sin. The implication was, if they had not sinned, they would have lived forever in their physical bodies. But if you sin, you're going to die. That's what he told them. Death, then, is the penalty for sin. Now, if you carry that throughout the Bible, and you bring that into the New Testament, you actually get to the cross. Because according to the Bible, what is the reason that Jesus died? Did he die to be a martyr or to be an example to us? No. Why did he die? He died for our sins. Because death was the penalty for sin, and if death, therefore, has been around long before there was ever sin, death cannot be the penalty for sin, and you, in a sense, just wiped out the very meaning of Christ's death. Maybe you didn't intend to do that. I'm not saying you intended to do that, but I believe that's what you've done. So Romans 6:23 makes sense if you understand that. The wages of sin is death, but the gift of God is eternal life through Jesus Christ our Lord. Let me conclude with just, again, a lot of you are familiar with these websites, some of you are not. I want to give you, if you want to do some more research on this, you can go to some of these sites to get more information. AngelsInGenesis.org is outstanding. Creation.com. These are probably the two best. ICR.org is the Institute for Creation Research. Another good one. This is if you're interested in the Creation Museum. That's really more about that. and there's a brochure on the table about that as well. And then ChristianAnswers.net is more of a general apologetic site, but it does have a lot of good information about the young position. So, I apologize for the warp speed. All right, I hope that you got something from that. And I probably don't even know what I said. I was saying it so quickly, I probably said several things wrong, but hopefully you got the gist of what I was saying anyway. Let me invite you to do this. Now, unfortunately, because we rent the room by the hour, we've got to immediately, for those of us that are from Cornerstone, and if anyone wants to help, you're welcome to help. But we've got to tear down the chairs and tables and pack them up in the back, because there is something else they're doing here tomorrow, and then we'll reset up for tomorrow evening. But we're going to be doing that. But after we're done with all that, if you want to talk, we're welcome to talk. I'm sure Dr. Reynolds would love to talk with you as well. But thank you for coming tomorrow night. We'll have 2 more sessions. Dr. Gerald Van Dyke is in the back. Can you lift your hand? He'll be speaking for us at 7 tomorrow. He's going to give a little bit of his story of being a creationist on faculty at North Carolina State University. All right? And so yeah, I think that might be interesting to you. And then I'll have